Hello there. I hope you are doing well, and I welcome you to another live lecture on MA 176 Probability and Stats 1. Now, for the previous sections, we looked at Introduction to Statistics. We've also looked at Distributed Statistics, Introduction to the Probability itself, and in this chapter, which is chapter 4, we shall be looking at conditional probabilities. Now, from the last time we met, we talked a little bit about this conditional probabilities, and we shall be looking at it and as well the Bayes theorem. Now, remember that from the last time I did say that the probabilities assigned to various events depend on what is known about the experimental situation when the assignment is being made. Now, subsequent to this initial assignment, partial information relevant to this outcome of the experiment may be available. When such information do exist, may cause us to revise some of the probability assignment that we made, and that is what the conditional probability is going to look at. So let's start with the Bayes theorem, or the objective for this chapter. Now, under this chapter, we shall be looking at how to calculate or estimate probabilities of joint events, such as the union intersection from the probabilities of individual events. We're also going to see how to interpret and calculate the conditional probabilities of events and determine the independence of events and the use of the independence to calculate probabilities. And finally, we shall look at the Bayes theorem to calculate conditional probabilities. So let's start with that. Now, once we are talking about conditional probabilities, all that we are trying to determine is the probability of an event given that another event has already worked. So probability of A given that another event, that is B, has already worked. So suppose that we let A refer to an individual having a particular disease in the presence of certain symptoms. For instance, if the blood test of this individual is being performed, then the result is negative, then it means that the probability of having the disease will change. Now, let's take for instance currently this global pandemic of COVID-19. Now, we know that once you begin to have some headaches, some fever, some chest pains, all these are what symptoms of what COVID-19. But if an individual who has this COVID-19 and they start to perform some tests to determine whether the person has headache, whether he has what chest pains and all that. Now, suppose that they test for what if the person is having fever and it comes as negative. That does not mean that the person does not have what COVID-19, but the chances that you don't have what any fever means that the chances of you getting COVID-19 is what less. But that does not mean that you don't have what any COVID-19. You could have other symptoms, but the fact that you don't have the fever doesn't mean that you don't have what COVID-19. So once we have situations like this in which there are other information which could alter the probability of one getting such diagnosis, it means that we will also have to consider those sort of events before making our decisions. So, and this is what conditional probability does. Also, we can think of an event that a randomly selected student in MA1 obtain all the requirements during the admission process. Now, you could see that once it comes to admission, for especially because we are doing MUMAT is doing the female the female gender mainstreaming policy. If we have two candidates, let's say a male and a female, although they all have the same requirement, but because of this female gender mainstreaming policy, the probability of selecting the female will be much higher than that of what the male. And this is because there is some sort of, should I say, a policy by the university of increasing the population of female students in the university. So although both candidates have the same probability, but because the policy prefers one over the other, the probability is likely to change. Also, the university is interested in applicants who are good with extracurricular activities such as sports. So in that same case, if you are good with sports and you are being compared with someone who is like only book person, then the one with extracurricular activities, his probability is going to go a little bit higher. Okay, so priorities are being given to certain people over others due to some special requirements. So anytime we are estimating probabilities of such event or such nature, we need to consider this sort of priorities or events that is beside this event that we are trying to look at. So suppose that the event of a student in MA1 getting admission is A, so the probability of A will not be that large. But however, if that the supposed student is an athlete who gets special admission priority, let's name this as event B. So for us to estimate the probability of this student getting admission, that will be the probability of A given B. So the probability that the student obtains admission, given that he is an athlete who gets special admission priority. So this is a conditional statement that the probability of getting admission, given that you have special admission requirement, and this is somehow going to boost the chances of these students, although will not be equal to 1, but will be somehow closer to 1. Okay, this is going to increase the chances of the student getting admission into the university. So once we have that, probabilities, conditional probabilities of event A given B is denoted by this expression that we have here, that is probability of A given B, and the formula for estimating such probabilities is being given by this equation. Okay, so probability of A given B is equal to probability of A intersection B all over probability of B. Just note the positions. So probability of A, the first one is just intersection all over the probability of the latter part, as we have here. So that gives us what we have here. Okay? So let's take an example. So we dealt with the profit margin of Gold Fields and that of Anglo Gold in previous sessions. So in that same example, we gave the profit margin of Gold Fields to be about 70%, and that of Anglo Gold to be about 48%, and their intersection to be 0.36. Now the probability that Anglo Gold's profit, given that Gold Fields profit is also under consideration, will be equal to probability of A intersection G, that is of that for Gold Fields, all over the probability of Gold Fields profit margin. Okay, that's what we have here. And remember, probability of A intersection G has been given here, all over probability of G, which we have to do 0.170. Okay, so the conditional probability given of A given G is equal to 0.514. So that is how we get to estimate these conditional probabilities. Also, let's look at this interesting one that we have here. Now, suppose that all individuals buying a certain digital camera, 60% include an optional memory card in their purchase, 40% also include an extra battery, and 30% include both memory card, and that of a battery. Okay. Now consider randomly selecting a buyer and let event A equal to those having memory card. Okay. and with B, those having batteries or purchasing batteries, and definitely their intersection between A and B is what we have here. So remember that probability of event A, that is those that include optional memory card, 60%, as we have here, and probability of those including extra batteries, we are having it to be 40%. And remember, 30% has both what? Card and what? Battery. And that is what we have as what? Their intersection that we have here. Now, given the probability that an individual purchased an extra battery, the probability that an optional card was also purchased. So this statement that we have here is more or less like the probability that the person purchased an optional card, given that he also had purchased an extra one battery. So this is the same as probability of A, given that he purchased what B. And remember that B is referring to what? An extra battery. So probability that the person purchased a memory card, given that he has already what? Purchased what? A battery. So this is a conditional probability, and we already know the formula. So all that we have to do is just put or substitute their values in there. Okay. Remember, P intersection probability of A intersection B is given as 0.3, and probability of B is being given as 0.14. Okay. So once we do that and put in here, okay, so that is what we have to be 0.75. So this implies that the probability of purchasing a memory card, given that the individual has already purchased an extra battery, that is probability of A given B is 0.75, meaning that there is 75% chances that the person is going to purchase an optional memory card, given that he has already purchased an extra battery. Similarly, we could also look at the probability of purchasing a battery, given that he had already purchased a memory card. Okay, in this case will be probability of B given what? A. We know the probability of A intersection B and have probability of A, which we have as this, okay, which will give us what? 0.5. So meaning that there's a 50% chance that the individual will purchase a battery, given that he has already purchased a memory card. So this is how this gets to work. Now let's look at another example involving publication in news magazine. Okay. Now with this news magazine, there are 3 columns entitled the art section, the book section, and that of the cinema section. Now reading habits of randomly selected readers, or reading habit of a randomly selected reader with respect to these columns are shown as. So remember that event A, a reader reading the arts column, is being denoted by A, that is event A, and also a reader reading the books column is being denoted by B, event B, and that of cinema to be event C. And we have their various probabilities estimated now here. Also, we also have A intersection B to be 0.08. We have A intersection C to be 0.09, and B intersection C equal to 0.13. Then finally, we have A intersection B intersection C equal to 0.105. And all this has been denoted in this Venn diagram. So you can see that we have 0.05 to be the intersection. We have A intersection B to be 0.8. That is, if you should look at all this, that will be A intersection B as we have here. That is 0.3 plus 0.05. That gives us 0.08. In that same case, A intersection C, that will be 0.09, and this all this portion as we have here, and B intersection C, that will be equal to 0.13, and that is exactly what we have in this section. That is 0.05 plus 0.08 giving us 0.13, and this gives us what? That. Now once it comes to the ABC, that is the A of everything that we have in here, this B and this C as we have in, and its complement has been given to be 0.151 as we see down here. So with this, let's see how we get to estimate the probability of A given B. Okay. Now probability of A given B, remember from the formula, and we have A intersection B to be equal to 0.08 and probability of B equal to 0.23 as we have right here. So once we do the substitution, we are having 0.138. Now let's look at another further example with this. Now suppose that with this same news publication problem, the probability that, what will be the probability that a selected individual regularly reads the out column, given that he or she regularly reads at least one of the other two columns. Okay, so in this case, we've been given that the probability that the person reads at column, given that he read at least one of the two other columns, meaning that either column B or column C, which is being represented by what? The union. So B or C, which is being represented by union. So the whole expression for this will be probability of what? A given B union C. And remember from the formula that if you should have probability of A given B, this is equal to probability of A intersection B all over what? Probability of what? B. Now, because of this given sign, it means that the first event here separated by what? This second, and this being separated by what? The intersection sign. So this first part is the same as this first part, and this second part is everything that we have here. Okay, so just doing everything in this formula, probability of A will be equal to what? Probability of A, which happens to be the first part, then intersection, the second part, which happens to be what? B union C. So that is why we have B union C at this point, or at this part of this equation. Also, looking at the denominator, this denominator is the probability of this second part, and for this second part we have B union C. So probability of B union C, and that is what we have here. Now from the Venn diagram, you could see that we have probability of A, and remember from the previous, we have probability of A to be 0.4, and remember that probability of A is equal to 0.04 as we have in here, plus probability of 0.05 plus 0.103. So with this section that we are trying to look at the intersection of A then B union C. Remember that B union C is everything that we have in here. And looking at A, okay, B union C is everything that we have here. And we also have what? A. And A2 is all that we have here. And remember that we are trying to look for their intersection. And their intersection is everything that we have what? In this region. So once it comes to this, we have 0.4, which is what we have here, plus 0.5, what we have here, and lastly plus what? 0.3. So this gives us what? The numerator part of this equation, divided by probability of B union C. And remember that B union C, we don't have it here, but we can calculate it from here. Now remember that B union C is everything that we have in here. So if you are to sum everything that we have in B and C, we are going to get 0.47, and that is going to lead us to 0.255. So this implies that there's going to be a 25% chance that an individual is going to read the art column, given that he or she has already read at least one of the other two columns. So that gives us this respectively. And what if we like to look at or determine the probability that the person reads the art column, that is A, and read at least one of the columns? Read A, given that he has read at least one of what the columns. And remember that in this case, we need to say the other columns, at least one column. Okay, so meaning that it could be A, that is the first column, that is column A, column B, or column what? C. So in this case, representing this by the conditional probability, we have probability of A intersection. All this happens to be the second part, all over probability of A union B union 1 C. As simple as that. Now, this that we have here is more or less like intersection of A that is A intersection A union B, and remember all this together. So meaning that the intersection is exactly everything in what? A. So if we should add 0.2 plus this plus that, we are going to get 0.14. And A union B union C is being given by 0.49. And remember with our 0.49, remember how we get to what? Calculate our union once we are having what? Three sets all together. Okay, three events happening together. That is probability of A plus probability of B plus probability of C minus probability of A intersection B minus probability of B intersection C minus probability of A intersection C plus probability of what? A intersection B intersection C. Remember that formula that we learned earlier on? We could use that to determine this our union of A, B, C, or better still, remember that we use this formula that probability of A is equal to 1 minus probability of A complement. Now looking at this whole set, for us to get this union, we've been given the complement to be 0.51, which we have to be 0.51. So if you want to get the probability or the summation, that is the union, which is the same as what? The sample space, the probability of the sample space. All that we have to do is just subtract 1 from 0.51, the complement that we have here from 1. And that is just going to give us 0.49. And when we simplify this, we are going to get what? 0.286. So in effect, all that this is trying to mean that there's about 28% chance that an individual is going to read the art column, given that he reads at least one of the columns. So this is how this also is being answered. And finally, let's get to see one more question under this publication of newspapers. And with this, the probability that the selected individual reads at least one of the first two columns, given that he or she reads cinema column. Okay, so once you are talking about one of the first two, it means that either the art or the other section, which happen to be the books column. So either he reads the arts or the books column. So that is why we have A union B, given that he has already read what? The cinema column. So given what? Event what? C. So the first part is what we have at this intersection, the second part which we have here, the probability of what? The second part. So A union B is just equal to everything we have in A, B, C, D. And remember that that will give us 0.4 and 0.3 0.05, then finally we have 0.108. Then finally we have the next one all over 0.137. And remember from our table we're given probability of C to be equal to 0.17. So that is why we have this as that. So with this, once we simplify this, we are going to get 0.459, meaning that approximately there's a 46% chance that an individual, a selected individual who reads at least one of the first two columns has already read the cinema column. So that is how we get to implement these conditional probabilities, and it's so simple. All that you have to just do is just get to know the formula and how to estimate these parameters that we have in there. That is as simple as that. Now, with this said and done, let's move on to another interesting feature called the multiplication rule in probability. Now, this multiplication rule or law provides a way to compute the probability of the intersection between two events. And this probability rule or law is being determined or estimated by multiplying the conditional probability equation by probability of what B. So if we should multiply both sides of this equation by probability of B, after rearranging, we are going to get probability of A intersection B is equal to what? Probability of B given A given B times probability of B. So this is more or less like trying to make this term here the subject. And this is very useful when we don't know the probability between the intersection between the two events, and we would like to know that. But once this is given, we are looking for it. It means that we have to this information would have already been given as well as this. So once we know these two terms in here, we can easily estimate their intersections and just find their probability. So let's see an example using the Goldfields and that of the Anglo-Gold profit situation. Now, in this case, we already know the profit chances of Goldfields as achieving that profit to be 70% and that of Goldfield to be 0.08%. Now, in this case, we are introducing a new term here, that is the probability of Anglo-Gold's profit giving that of Goldfields, and we'll be giving that to be 0.514. Now we estimated this earlier, 0.154. Okay, so with this, if we would like to know the probability of A intersection G, and remember we know this and we know the probability of A, we can easily estimate the probability of their intersections. Now using the multiplication rule, which we just learned from here, we can easily estimate their intersection. So if you like to know their intersection, this will just be equal to this probability times that, okay, and this will be equal to 0.48 times their conditional probability here, and this is just going to give us 0.2468. So that is that. Now let's try to do the same thing with the brands of DVD players being sold. So with this brands of DVD players, suppose that Malcolm sells 3 different brands of DVD players. Now of these DVD players sales, 50% of brand 1, which is least expensive, 30% are brand 2, and 20% are brand 3. Now with all these DVD players or brands, each manufacturer offers a 1-year warranty on parts and that of labor. So it is known that 25% of brand 1 requires warranty repair work, whereas the corresponding percentages for brand 2 and brand 3 are 20 and 10% respectively. So The question follows. What is the probability that a randomly selected purchaser has bought a brand 1 DVD? What is the probability that a randomly selected purchaser has bought a brand 1 DVD player that will need repair while under warranty? So with this, we have the event. Let the event A be equal to the kind of brand the purchaser had purchased. And remember, we have for brand 1, brand 2, and what brand 3. So from the question, we have the probability of purchasing brand A to be equal to what 50, and probability of purchasing brand B to be equal to, and probability of brand 3 to be equal to what 20%. Now, once a brand of DVD player is selected, the second stage now involves to observe whether the selected DVD is going to need what warranty repair. So with this, let's create another event such that B denotes that the brand that is being bought will need repair, and B complement, meaning that that brand is not going to need what repair. So with the given information that we have from the question, we can deduce that the probability of purchasing brand 1 given or needing a repair given that it is brand 1 will be equal to what 0.25%, 25, and the probability of the brand needing repair given that it is brand 2 is equal to 0.2, and the probability that the brand or the DVD brand will need repair given that it is brand 3 will be equal to what 0.1. All this information is being deduced from what the question. Now let's see how we get to what represent this on a tree diagram. Yeah, so with this situation you can see that we have 3 brands of DVDs. So we have brand 1, brand 2, and brand 3. Now brand 1, they are 50%, or the DVD 50% of them are brand 1. Of brand 2, we have about 30% of them, and brand 3 we have about 20%. Now with this brand, it's either is going to need a repair or it's not going to need what repair. So that is why we have this point denoting that you need a repair or you don't need a repair. So if you need a repair, that is being denoted by probability of B that is needing a repair given that it is what brand 1. And if you don't need a repair, that will be a probability of what B complement, that is you don't need a repair given what A1. Okay, that is for brand 1. And from the question we do have that the probability of brand 1 needing repair is equal to what 0.25. So meaning that 0.25 will need repair while the remaining 0.75 would not need any repair. Now similar thing happens to brand 2, and with this brand 2, those that will be needing repair are 0.2, and those that will not be needing repair is 0.8. That is will be their probability. And for brand 3, those that will need repair is 0.1%, that is 10%, and those that will not need repair is what 90% of the brand 3. So if you are to estimate that the probability that a randomly selected purchaser has bought brand 1 DVD that will need repair while under warranty. So in this case, we are looking at brand 1 needing a warranty. So looking at the tree diagram that we have here, we are just going to follow this pattern that is for brand 1 and is going to need what? A warranty. So all that we have to do is just multiply our probability of A1 by this probability that we have here. And this is just going to give us what? The intersection between A1, that is B, giving what? A1. So probability of B giving A1, that is 0.25, and probability of A1, that is 0.5. And once we multiply that, it is just going to give us what? The probability of what? B intersection A1, that is just going to give us what? 0.125. So it means that definitely about 12.5 5% of our brand 1 DVDs are going to what? Need repair. In that same case, we could do same for what? The other elements. Suppose that we like to know the probability of that DVD brand needing repair will be brand 2. That also can be estimated here, and that of what? The third one also represented right here. So there's also another question involving this DVD brands. So with this, what is the probability that a randomly selected purchaser has a DVD player that will need repair while under warranty? And remember, with this one, we did not specify the specific brand. So in this case, we are going to do for each and every one of them. So this could be the probability that brand 1 and will require repair, or brand 2 which will also require repair, or brand 3 which will require repair. And remember, we estimated this one from the tree diagram as this, and this as the second one, and this as the third one. So if we are to add all this is just going to give us 0.205, and that is going to be the probability that the purchaser has a DVD player that will need repair while under warranty. Now let's look at the last and the third one for this session. Now with this one, if the customer returns to the store with a DVD that needs warranty repair work, what will the probability that it is a brand 1 DVD player, 2 a brand 2 DVD player, and 3 a brand 3 DVD player. So this is taking it back to the conditional probability. So the probability that the DVD player being bought will need warranty given that it is brand 1. So this is just going to be what? Brand 1 given that it's going to need repair. So remember from our conditional probability, and we already know A1 intersection B, which we were able to estimate as 0.125. So this will be 0.125 all over probability of B. And remember, we estimated probability of B to be equal to all that we have in here. Okay. So if you go through that, we are going to get 0.61 for the probability of A1 given B. Now what about the second one, brand 2 DVD player? So the probability of brand 2 DVD player given that is going to need warranty repair work will be equal to 0.06. I remember we estimated our 0.06 from here all over our B, which will give us 0.29, meaning that about 29% of brand 2 TVs will definitely need warranty work. And finally, the third one, which happens to be brand 3 DVD player. So with a brand 3 DVD player, given that it's going to need warranty repair work, will be equal to, we have two approaches in here. You can go with the conditional probability, where this is going to be a probability of A3 intersection B all over probability of B. And remember, we've estimated our probability of A3 intersection B to be, that is 0.02 all over 0.25, and we are going to just get 0.29, or that is 1.10, or better still, we can add these two and just subtract from 1 as we have here. Okay, so 1 minus 0.61 minus 0.29, okay, and this is just going to give us everything that we have here at 0.101. So this brings us to the end of this session. Now under this session, we've looked at how to make use of these conditional probabilities and how to estimate it, how to explain this, when to even use it, and also we also did one or two about the multiplicative rule once it comes to probability. Now with this one, you could see that it's very important in the sense that there are so many situations in which you get to calculate the probability given that a certain event has already what occurred, or an extra information is available which is going to what impact on what the probability that we have. So this brings us to the end of this section. Now we have one more section to tackle, which is called the Bayes theorem. It's also very easy. So I'll see you in the next lecture for this last section.